A disclaimer before this video starts. There are firearms in this video. During production, no loaded firearm was pointed at a human. During firing procedures, the proper safety was used and was conducted by several individuals with intensive history and background in firearm safety and use. Please do not repeat this at home.
Man, someone just left this unattended Subaru.
Has your car ever been broken into or stolen? In fact, Denver has had 51 armed carjackings this year, and an average of about one every 2 days.
And that's a big problem, but we have a solution.
The Auto Sentry fits in your trunk. The perfect defense against a carjacker. Now, let's see what it looks like when operated in the field by our own specialists on site.
Go. Oh, come on, do it. There it is. It got it.
Let's take a look from a different angle. Here we go.
Ready?
Mm-hmm.
And one last time in slow motion. Now, let's see what it would look like in real life. No person was harmed in the filming of this video. These are professional actors.
Sure, it's a bad day to be a Subaru owner. Oh, crap.
So for the next iteration of the electronics and the skeleton of all of the motors, things have been a little bit more refined. We have fewer wires. In the final design, this breadboard and this breadboard are not going to be there. We're going to just have longer wires connected to the 5 volt, and that's just so it's more ergonomic for the user. And this entire batch of electronics is going to be inside of a box, and that's making it way more safe for the user and also makes it look nicer. The code has also been shortened substantially, but it all works just the same. This is the start button. You can press the button and it starts moving. And say there's something close to it. It'll see that, and then when it goes back to do its pass, it'll return to that point. And then when it returns to that point, it flips the servo, which acts as the trigger. And then it continues to do more scans. Now, on the final design, it's going to be amplified with a higher gear ratio, so it will not be moving this slowly, it'll be moving much faster. And it is constantly reading both the ultrasonic sensor distances and the number of steps.
Alright, as for the mechanical design of the final product, we have the main mounting piece printed right here. So as you can see, there's a AR-15 handle printed on this gear with the mounting mechanism. So basically this will be screwed onto the lower receiver of the rifle we would like to use to mount it to the rest of the turret. On the bottom part we have inner gear teeth for when the servo motor rotates the inside to point it in different directions. There'll be a gear rotating on the inside, which is actually currently printing. It'll look something like this. So it has 44 teeth, or 36 teeth on the inside. That has, this one has 144, so it has a 1-to-4 gear teeth ratio. And then in order to mount the servo motor itself, with the gear on it. There will be a secondary bottom base plate with a little ring sticking up that this will sit on, and this top gear piece will spin on this ringed piece, and then all the electronics will sit resting on top of this base plate.
For the entire configuration, we're going to have this piece up on a tripod stand that we have the wood for. We do not have the base plate yet, so we have not made the entire tripod. But inside of the base plate, we are going to attach the servo motor so that it sticks the gear right next to the base for the AR. And as the servo turns, it will stay stationary, and this entire plate is what rotates our 180 sweep in order to satisfy our auto sentry and to make sure that it does not go in a full 360 defending whoever's behind it.
Close to it. It'll see that on its pass. And then it'll go back to where it saw it and activate the trigger.
And finally, here is a trigger mechanism working. Here's a little blooper of one of our filming sessions, we could say. We thought that this was funny and wanted to include it in our little video as something interesting.
Cut it.
We're cutting it.
All right, do that again. Let's go.
Okay. Bro, your brake was on?
That's going on the blooper.
For our circuit design, as we can see here on the left, maybe not very well, but there is an ultrasonic sensor that we used to determine the closest object to rotate our firearm towards. There is a stepper motor on the bottom of our Mega Arduino that rotates our contraption using a gear ratio of 36 to 144. This allows us to rotate using a stepper motor that is not as high of capacity. As you continue around the Mega Arduino that we used, you'll notice that we used two 9-volt battery sources to power everything. As you continue around to the right, the top right, there is a button. As you press the button, this is what activates and stops the entire circuit. We decided to include this as another secondary safety precaution. The secondary stepper motor that is on the top of the Arduino is used to pull the trigger when the firearm has been rotated back to the correct angle. Overall, this was our basic circuit design. To decide what we were doing for our entire project, we came up with the problem of carjackings. How could we solve that, use Arduino, and talk about what we love to do at the same time? We decided that the Second Amendment was a great way to go down. We all have a passion for firearms, and therefore are able to go down that path with our Arduino. So as we looked and decided what different kind of things we could do with that Arduino, we decided that an auto sentry was the best way to do it. We could do it by using a gear and our stepper motor, and then mounting an ultrasonic sensor to position it, and a stepper motor to pull the trigger as well. As we came up with more and more iterations, we eventually 3D printed the base, screwed some wood tripod into it for more of a sustainable base, and was able to come up with our final design that you can see in the video. So come on down to Glass Cannon Manufacturing to get your Auto Sentry defense today.